Hello, ladies and gentlemen. This is Mr. Heeren, and this is lesson 1-2 for trigonometry, simplifying radicals. And it might look familiar to you because you've probably done it before, either in algebra or maybe in middle school, but it's been a while, so it's worth reviewing. So let's just take a minute and kind of look at what it means to simplify radicals. Rule number 1, anytime you see simplify, that means you cannot have a decimal. You are not allowed to just punch it in your calculator and give me some big, long, ugly decimal for an answer. Simplifying means you have to make it easier to deal with when you are just working with radicals. So, be able to simplify, add, subtract, multiply, and divide radicals. So let's start with this. When you break down the radical, these are considered perfect, and you might recognize that those are also considered the perfect squares. So perfect squares are 1, 4, 9, 16, 25, 36, and so on. So you might want to consider familiarizing yourself with the perfect squares up to 15. So like 1 squared, 2 squared, 3 squared, and so on. So square root of 25 is obviously going to be 5. Square root of 79 is 7. Square root of 121 is going to be 11. So those would be considered your perfect squares. Non-perfect is anything that is not a perfect square. Pretty straightforward. But you are able to break down some of these. So square root of 28, you can break 28 into 4 and 7. So I would have square root of 4 times square root of 7. So the square root of 4 is just going to be 2. So 2 square root of 7 would be considered simplified. All right, 50, 75, 32, those are all ones that can be split apart as well. So 50 and 75, 50 can be split into 25 and 2. Square root of 25 would be 5 square root of 2. Okay, just to give you an example, we'll go over some more of these later. But these would be considered perfect, which would be your perfect squares. These are considered non-perfect. So these would be ones that you would be considered to cannot break down, and here's why. So if I look at 21, 21 splits into 7 and 3. So the square root of 7 times the square root of 3. Neither one of those are perfect. So this is as simple as I can make it. All right, likewise for the square root of 30, well, even if you start playing around with all the different factors, so you would have 3 and 10, so square root of 3, square root of 10. You could also do, 15 and 2, square root of 15, square root of 2. None of those work. There's no perfect squares there, so square root of 30 is as simple as you can get. Square root of 101 is similar. You can't break those down into anything that would possibly have a perfect square. Fractions, couple of concepts that you need to know. One, you cannot have a fraction inside the radical and no radical in the denominator. The reason for that is this. Square root of 2 is what we call a irrational number. All right, you put it in a calculator, you get a big, long, ugly decimal that never ends and never repeats. That is the definition of irrational. Irrational means never ends and never repeats. So square root of 2 never ends and never repeats. So take a moment, think about what you're doing. You're actually taking 6 and trying to divide it by something that never ends. So you can't really do that mathematically. Now there's a couple workarounds, we'll get to that in a second, but realize that you can't do that because you cannot have a square root in the denominator. Likewise here, same idea, because mathematically this is the equivalent of square root of 2 over square root of 5. That's still an irrational number, which means it never ends and it never repeats. And you can't divide by something that's never going to end or never going to repeat. So this would be the correct form. So the square root's in the top, which is fine. This needs to be a whole number of some sort. All right, so this is the correct form. Square root on top, okay. Number on the bottom, okay. No square root. So just kind of be aware of that when you're dealing with these things. Okay, so if I'm simplifying the radical, basically what I'm trying to do here is I'm trying to break it apart and I'm trying to find perfect squares. Okay, so it's helpful to realize what those are. So if I'm trying to find perfect squares, well, this first one's pretty easy. 81 is 9 times 9. So I know that 81 is just going to be 9. That's just a perfect square. Square root of 81 is 9. Square root of 28, well, 28 by itself is not a perfect square, but I can split that into 4 and 7. And 4 is a perfect square. Square root of 4 is just going to be 2. So simplified, that's just going to be 2 square root of 7. So that's 9, that's 2 square root of 7. Letter C splits into 11 and 1, square root of 11, square root of 1. That doesn't really do me any good. Square root of 1 is in fact 1, but now I'm back to where I started with square root of 11. So this one cannot be simplified. That one's not going to work. So here, a couple more. This is where you might have to get a little bit clever and start playing around with what might work. So 48, and 48, you can mess around with. Most kids are going to do, for 48, they're going to probably do 4 and 12. And you split 4 and you split 12. So a lot of kids think, oh, it's 2 square root of 12. You can keep going with this. 12 can be split into 4 and 3. So once again, the square root of 4 is 2. So I have 2 from this one, 2 here, square root of 3. So my answer actually becomes 4 square root of 3. All right. So you've got to start kind of recognizing that just because I pick 2 numbers doesn't mean I necessarily am done, because I can still maybe figure that one out. So 280. So just kind of playing around with that. I might go 280. I might go, well, that could be 4 and 70. Let's see, 70. Let's see, 7 and 10. 10 is 5 and 2. So that might be about as far as I can go with that one. So square root of 4 is going to be 2. 70, there's no way to get another perfect square though, so it might be just 2 square root of 70 for that one. Letter F, this one, if you're a little bit clever, anytime you see 600, well, I might go 100 times 6, and this is where I can recognize that the square root of 100 is just 10, so my simplified answer would just be 10 square root of 6. So just because, you pick 2 numbers that work as factors of that, make sure to check both, because you might be able to manipulate both numbers like we did up here. Well, I can keep manipulating 12 and looking again and see if I got another square root in there. Adding the radicals. It's a little bit like, you can only add like terms, so it's a little bit like a variable in that state. And what I mean when I say that is this. You could add 2x and 2x and get 4x, but you can't add like 2x and 2y. Okay, you can't add those together. You don't get like, 4xy. That doesn't work. You can't do that. Similar idea with radicals. You can only add them if they are exactly the same. So for letter A, this is like 1 square root of 3, 1 square root of 3. So that's just going to be 2 square root of 3. Letter B, 2 square root of 5 and 1 square root of 5 is going to be 3 square root of 5. Now letter C, right now I can't put those together, but I need to recognize I can simplify square root of 18. So square root of 18, I'll keep that 3 out front. Square root of 18 can become square root of 9, square root of 2. So the square root of 9 is 3. So this one actually is 9 square root of 2 plus 5 square root of 2. So that one I can put together for a final answer of 14 square root of 2. Notice this number out front here, I just keep it out front and then work with the square root. And then once I go from square root to a whole number, then I can multiply it. So realize that, you know, these two are just different ways to represent the same thing, but now I can manipulate that and multiply those two. All right. So here, square root of 21 and 6. Well, 21 can only split into 7 and 3, so there's no help there. So square root of 1, 6 can only split into 3 and 2, so there's no help there. So this one is simplified. Letter E, 2 square root of 32. Well, 32, and this is where once you start getting good at this, you can be a little more clever. 32, you need to take a moment and realize that 32 is nothing more than 16 and 2. And why do I take those two numbers? Well, I did that because I know square root of 16 is a perfect square. So square root of 16 is really 4 times square root of 2. So that means this first term becomes 8 square root of 2. Second term is still 5 square root of 2. That's simplified. So it becomes 13 square root of 2. There's my answer. So I'm always looking to see what can I simplify. Multiplying the radicals, there's a couple different techniques you can do. What might be easier, I mean, first off, I can always just multiply everything together underneath and get one whole number and then try and break that down. I want to be a little more clever about this because multiplying, you can get away with a little more than adding and subtracting. Adding and subtracting, you have got to have the exact same number underneath the square root. Multiplying, you can get away with a little more. So what I like to do is try and break it apart. So I'll go 4 and 2, and I know that the square root of 4 is 2. Here I'm going to break it up into 9 and 2. So that's going to be 3 square root of 2. So I have 2 square root of 2 times 3 square root of 2. So now here's what I'm going to do. I'm going to multiply the outsides. I'm going to multiply underneath the square root. But that becomes 6 square root of 4. Well, now check this. Look at this again. All right, can you simplify it? In this one, absolutely. Square root of 4 is just 2. So this just becomes 6 times 2. So my final answer will be 12. Okay, so all I did was break that apart by number. You know, if you take 18 times 8, you know, you might recognize that if I put that all together, 8 times 8, or 18 times 8 is going to be 144. You might recognize that as, you know what, that's 12 times 12, so my answer is just going to be 12. If you're good enough to remember that, awesome. Not everybody does. I try to take it one piece at a time and see what I can put together and keep simplifying. So here, 45, I like 9 and 5. 15 becomes 5 and 3, but that doesn't really help me. Square root of 9 becomes 3. This becomes 5 times 5 times 3, which is 75. But I can simplify that. I can keep going with that, and I'll do that over here. So I still have this 3. 75 can be rewritten as 25 and 3. Well, the square root of 25 is just going to be 5. So my answer is just 15 square root of 3. Okay, so be careful with that. Always double check to see, can I keep simplifying this number once I put some things together? So here, simplifying. Um, Once again, I cannot have a square root in the denominator. So what I do is I multiply by 1, and I put 1 in the parentheses, because here's what I do. Remember the rule. I can have a square root in the numerator. The square root in the numerator is fine. I cannot have one in the denominator, so that right now I cannot do. So I kind of cheat a little bit. And what I mean when I say that is, whatever the square root is, I multiply the top and bottom by that. So multiplying fractions, you multiply top times top, bottom times bottom. So the top is square root of 2, square root of 3, and that's fine. I can have a square root in the top. The bottom is square root of 3 times square root of 3, which is square root of 9, and the square root of 9 is just 3. So there's my answer. There's my simplified answer. Now for letter B, I want you to recognize something. A lot of kids will just go flying in here and say, oh, I can just do square root of 16 top and bottom. Well, yeah, you can, but put a little thought into this. The square root of 16 is a perfect square. All that becomes is 3 out of 4. Square root of 16 is just 4, so it's just 3 out of 4. Letter C, if I've got a fraction, the entire fraction is underneath the square root, I can rewrite that as square root of 5 over square root of 6. All right, I can split the square root into the top and bottom. Now I only have to deal with the bottom and fix that. So I multiply just the bottom there. So square root of 6 times square root of 6, put that together underneath, which is just 6. Top, square root of 5 times square root of 6 is just going to be square root of 30. There's my answer. Okay, so the big picture here is I'm just going to multiply the top and bottom by the bottom square root, and just to get a square root out of the denominator. But I've also got to recognize that if I see a perfect square, I can make my life a lot easier by just doing that. So now, if I look at this one, these are a little tougher. So if I go square root of 21 over square root of 18, I can simplify square root of 18 before I keep going. So if I do that, keep square root of 21 on the top. Square root of 18, you might recognize square root of 9, square root of 2. So this could be 3 square root of 2. So now I want to multiply top and bottom by just the square root of 2. Okay, here's what that does. Top, square root of 21 times square root of 2. That's multiplication. So it'd be square root of 42. Bottom, I have square root of 2 times square root of 2. I still have that 3, so I bring it along. Square root of 2 and square root of 2 just becomes 2. So it becomes square root of 42 over 6. There's my answer. That's a 6. Now, some of you guys might be saying, hold on a second. I do notice that 21 and 18 can both be divided by 3. So you can absolutely simplify the fraction while it's still underneath the square root. That is legal. You can totally do that. Like here, both the top and bottom can be divided by 9. All right, 9 is a common thing. So I can take 81 divided by 9, and I can take 18 divided by 9. All right, that's perfectly fine. So when I do that, I could rewrite this as the square root of 9 over the square root of 2. All right, so I can simplify that. All right, I skipped a step. I could have rewritten it as square root of 9 over 2 and then rewrote it like this, but I just kind of skipped a step. All I did was simplify the fraction underneath. Well, now you might recognize that the square root of 9 is just 3. So now I have 3 over square root of 2. Now I cannot have a square root in the denominator, so this is my multiply by 1 because I have the same thing on top and bottom. So it's 3 square root of 2 over 2. Okay, these two multiply together, and I take the square root, which is just the number. So there's my simplified answer. All right, so take a moment, hit pause, give these a shot, and then come back and check your answers, see how you did. Okay, let's see if your answers match up to mine. When I look at 40, I see 4 and 10. So square root of 4, square root of 10. So 2 square root of 10 is my answer. For number 2, I'm looking at this 20 thinking I can simplify that. So I keep the 3 square root of 5, can't do anything with that. 4, and then 20 can split into 4 and 5. The square root of 4 is just 2. So 4 times 2 square root of 5. So this becomes 8 square root of 5. Sorry, that's an 8, I promise. So I have 3 square root of 5 and 8 square root of 5 for a final answer of 11 square root of 5. So for 8 over 7, that becomes square root of 8 over square root of 7. So I want to multiply top and bottom by square root of 7. Square root of 56 over 7. All right, this is multiplying by 1. Okay, so there's my answer. I would take this answer. I would love it if you guys could be a little clever and realize that 56 can be split up into 14 and 4. And 14 is obviously, or square root of 4 is just 2. So 2 square root of 14 over 7. That would be an awesome answer. This would be very nice. Okay? I would take this, but come on, you're trig kids. Take an extra step and do the perfect answer. Okay, so look through this, pause, rewatch as needed. I should be back soon to answer any of all questions. Have a good day.